Good morning, everybody. I'm happy that I can welcome you at the second day of the World Organizations for Systems and Cybernetics Congress, organized together with the Russian Academy of Sciences. Well, maybe I could take the opportunity to just announce the moderators of the sections. Yeah. Today's sections will start at 12:20 Moscow time, and we'll start with 1.3 with moderated by Raul Espejo and Vladimir Lepsky. The next to that in room section 2.3, that will be moderated by Zorada Medveza-Bendek. Zorada, hello, good morning. Oh. Section 3.3 will be moderated by Jerzy Josefik. Is he here already?
Is he around? No.
Nope, he's not here yet, but he'll turn out. And section 4.3 is going to be moderated by Vojko Potochan, who I think also is not here yet, so we can expect more participants joining during the day. And in the afternoon, we also have a section 3.4, which will be moderated by Yuri Slovokhov. Okay, I think Yuri is also not here, and that's okay. But let's not keep it too long. Let's start with the day and let's introduce.
We are already, yes, because Mike is asking me to give him 20 minutes of my talk, so.
Oh gosh, and Mike is giving me 20 minutes, so that's going to be perfect.
I think what is good to know is that Mike has plenty to say, which is very good.
Can I just make a suggestion to you, Raul, that we can hardly see you? You need to adjust your camera so that we can see you better.
That's a good point. Thank you very much.
Yeah, you look too comfortable.
That's a terrible.
We're all working.
That's a terrible suggestion, Raymond. We don't want to see more of Raul.
Terrible suggestion.
Okay. Well, I assume some of you actually met Professor Raul Espejo. Some of you actually seen him. Some of you actually heard of him. But right now, I would really love to introduce organizational cybernetics for the future of humanity. Raul, please, the floor is yours.
I think I need to share my file, which let's see that I have here. Right. And right. And I'm going to reduce these so that. Right. Well, I am delighted that we have had two very good days yesterday and the day before yesterday. I hope today will be even better, and we have plenty to talk about. In this occasion, I want to go through run a material that I have presented in many occasions, but I want to give somehow a complete picture from my perspective of how is it that I understand all this work that I've been doing for some time. I want to talk about the following points: early cybernetics, the law of requisite variety, and black box description of complexity. That's going to be my first topic. Then I will move into the VSM and focus on relationships and operational description of an organizational complexity, of an organization's complexity, and continue that with the Y-plan methodology, which is work I have done for a few years now, and move into the enterprise complexity model, which is something that helps me to work and study issues of general interest. And then I think more or less midway of our discussion, we will discuss digital complexity, society, and big data. And that perhaps is where I am interested to put some ideas that help us to use the ideas of organizational cybernetics in the world in which we are operating. This is the way I will start here, which is something that you know very well. Well, this is management complexity and requisite variety. This is work, of course, of Ashley, but in the early 1980s, I did some work in this. And the outcome of that work is presented in the diagram that you have in front of you. That is the management of a black box and with some controllable resources coming in and outcomes going out. And then a regulator establishing some desirable states or the kind of performance that is desirable or acceptable. So for each of these, we have the variety of outcomes. I use the word the V and the subscript O, and for performance, V subscript T, and I have for the environmental disturbances, V and the subscript D, and for affordances and the variety of responses, V subscript R. What is what the law of requisite variety tells us is that the variety of the outcomes is always larger or equal than the ratio between the variety of the disturbances, the environmental disturbances, and the variety of the responses. This is the way in which most people understand this law when they say that the variety of the situation has to be matched by the variety of the regulator, but of the responses, sorry. But what really reflects adequate regulation is when the variety of the outputs or outcomes is contained within the variety of desirable states. And that is what we look for in all these situations. But what most people stay with is the idea that the variety of the disturbances has to be matched by the variety of the responses. That's and what we have in the middle is a black box, which produces outcomes and performance. This black box, in the way that is presented there, looks like a trivial machine. So we need to move beyond that and start to think about that black box as a non-trivial machine. And that is what I think Stafford Beer did in his famous viable system model. And this viable system model related to an operational description of the situation of the organization, and the focus of this is on relationships. So rather than focusing on functions, as most people do in terms of the viable system model, my personal interest and where I can move away from a trivial description of the situation of the organization into a non-trivial is when I start to think about relationships. And these relationships are the ones that I am describing on the left side of the diagram, where you can see that we start with what the trivial machine gives us, which is performance, where it is what the output of the organization to its environment. And based on the ideas of productivity and latency, which are related to the operational environment and the problematic environment, as reflected in the diagram that I am presenting to you. And the next relationship that I think is very crucial is cohesion. And this cohesion is all about relating or recognizing aspects of coordination, auditing, and resources bargaining. That's the number 2 that I have there in the diagram. So in the diagram, you can see that these 3 relationships are or these 3 communications are constituting the relationship of cohesion. And one aspect that seems very important is that around these 3 aspects, we have very much the situations that are critical for the, and as I will explain later on, are critical for the well-functioning of an organization. We need to establish adequate coordination. We need to develop trust in the, within the organization so that the people in the organization can handle interactions without the need to know everything that is going on. And that is aspect central to the idea of cohesion. And the third relationship is the relationship of policy, which, as you can see with the numbers 3 in the diagram, are related to the interactions between intelligence and cohesion, intelligence being the capacity of the organization to deal with the problematic environment, and cohesion, the capacity to deal with the internal issues, internal problems within the organization. And then the real interesting aspect is that policy is about managing the interactions between these 2 functions, and in this managing, they want to achieve a proper understanding of the balance between the external world and internal world. Then the relationship 4 is inclusion, and that is one that often I see missed, and that is how is it that we get the local somehow connected to the global through as many recursion levels as are necessary in the situation. And that is the number 4 here, where we build up communications to relate the operational environments to the problematic environments, and from there to the total, in both directions, into the total organization. Perhaps the final relationship that is somehow often understood or misunderstood as simply building up a recursion on top. In this case, I'm not considering that. I'm saying is about organizational citizenship in its context. And in here, I very much develop all the ideas I've been working in connect to self-developing reflexive active environments, which is the proposition of Vladimir Levsky, where we are talking about the context in which the particular organization is operating. And that's what we will be referring to through different parts of this conversation to third order cybernetics. So that's the operational description. Now, what this operational description is doing is giving life to the black box that I showed in the previous diagram. In the previous diagram, I was showing something that had only inputs and outputs. Now I think we are giving some content to this black box in terms of relationships that absorb huge amount of variety, and it is only at that level that we start to talk about outcomes that reflect all the values, interests of the people within the organization. The third aspect I wanted to refer to is the Y-plan methodology and the enterprise complexity model. What is interesting in here, sorry, is that I am here showing a learning loop. This is about learning, and we have observing, naming, designing, and implementing the four, shall we say, basic activities of a learning process. Now, in the Y-plan methodology, we operate with two loops: the big data of enterprises, actors, and sustainable environment, which is what gives supports the development of the two loops that I'm referring to. One I call the cybernetic loop, and the other one I will refer to as the learning loop. In the cybernetic loop, we are observing what I have just said, and based on that, we are structuring something. And that's what in methodological terms we call naming. And these are names for enterprises in focus, or for whatever problematic ecology we may be talking about. And these names are used to work out diagnosing the enterprise's organization structure. And for that, there are methods that help us to do that. I call that the Y-plan method. And but perhaps the crucial aspect here is improving the cybernetics of the enterprise in its environment. So at the end of the day, the cybernetic loop is there to improve the cybernetics of the enterprise in its environment. How is it that we increase its response capacity and make it more coherent with the performance required? And at the outer loop that I am showing there with the white lines are related to issues of concern, to problem situations, environmental ecology, and organizational systems, liquid enterprises, performance in sustainable development goals, all these things that are really of our interest. And based on the enterprise complexity model that I will mention in a minute, we start to discuss about self-organization and what perhaps is critical, correcting variety imbalances that we find in the situations that we are dealing with. That's perhaps where I see most of the difficulties in achieving adequate performance and moving in the direction of a desirable society. So what in the end I want to mention is that the interactions between this inner loop, the cybernetic loop, and the outer loop, which is the learning loop, are reflexive. There is reflexivity between them. So as we hit the problems and we start to try to cope with them, I think what we do is we learn about the situations, and this learning is somehow passed back to the organizational system, and the organizational system is with this better understanding of the situation, changes its structure, improves its structure, and somehow moves in the direction of improving the situation structurally. So the inner loop there reflexively is improving the structure for the situation. And at the same time that that is happening, as the situation structurally improves, the next thing that we can talk about is the situation, the problem situation itself, that with better participants, more effective contributions of relevant actors and agents, produces some kind of a better understanding of the situations, and this better understanding of the situations is what triggers, what leads to a better management of the situation and the complexity of the situation. So that's essentially this reflexivity is essential for the general problem solving of the situation. So what is the enterprise complexity model or network? When we are implementing situational transformations, it requires it requires correcting variety imbalances in the participants' interactions to achieve desirable purposes. From a design perspective, I think this is the most demanding aspect of problem solving. Correcting these imbalances is the approach to give requisite variety to interactions, recognize the need for affordances, and therefore the means to move in the direction of improving situations. This appears is perhaps something that has been heard many times. What I have found very often is that people don't understand very well the idea of requisite variety. And one thing I will say very briefly, if I could, is talk about residual variety. So when people say to achieve variety, the balance, the complexity of the situation has to be matched by the complexity of the regulator, I think is not right. What it happens in most of these social situations that we are dealing with is that most of the variety of these situations, most of the complexity is managed within the environment or within the organization. And that is happening through self-regulation and self-organization. So as these processes of self-regulation and self-organization absorb variety, what is left for the variety matching process is the residual variety that has to be managed by, in this case, the organization or management. And that is something that changes radically in a design direction, the management of complexity. Because what we are trying to do all the time is improve the complexity, the processes of self-organization and self-regulation, and through that reduce the demands on the management that comes at hand at that point. And for that is that Stafford Beer proposed quite a number of years ago, perhaps mostly in his book in 1985, variety engineering. So variety engineering is where we try to help these processes of self-organization, self-regulation, and matching varieties, and through that achieve results that we want. Now, what is important in this case is that most of the time, complexity this management of the situation is central to today's big data management. Through the extended model of the viable system, that is what I'm calling the enterprise complexity model, organizational systems can improve this management. And that, in a way, has a direct implication or a direct possibility to, sorry, something went wrong here. Right. This has the possibility to improve the management. So together, the viable system model, the Y-plan methodology, and the Y-plan method can help developing the enterprise complexity model, which is visualized as a distributed governance model of an ecology of evolving enterprises, guiding the enterprise's collective self-organization. So in a way, most of the problems we find today would be relatively silly to propose that the United Nations has to develop a viable system model within its own structure to manage the complexity of the world. That simply is not the case. And most of the institutions that we are dealing with have no recognition of this issue of viability in the way that we are using. But yes, I think what we do have is enterprises that recognize situations, and through this recognition, they work out different possibilities of other networks that may help in building up the response that is required in a given situation through processes of coordination, trust building, and so on. The challenge is local self-organization towards more global values and policies, creating, regulating, and producing products and services that are deemed necessary to handle societal problems like COVID-19, climate change, the global ecology, and the economy. An enterprise complexity model requires reflexively an ongoing reconfiguration of resources, communications, and relationships to produce a responsive organizational system to handle problem situations. The issue is reorganizing society to take the greatest advantage of new digital technologies. This can be supported by the construction of appropriate enterprise complexity models, which in fact more recently have been calling enterprise complexity networks. The new technologies will facilitate the necessary changes in society. So what the enterprise complexity network is offering is the capacity to relate organizations, resources distributed throughout the concrete situation of concern, relate through digital technology and manage the big data that is somehow produced today with the situations of technology is produced in society. So organizational cybernetics, and I'm proposing this, organizational cybernetics offers a revolutionary paradigm to manage big data. Our increased understanding of organizational structures and the fast development of digital technologies offers new opportunities towards fair and better societies. But big data, as we know, offers opportunities as well as restrictions for autonomy and freedom. In today's digital society, organizational cybernetics offers a revolutionary paradigm to manage this data. This is very interesting because in the past, managers and politicians had the chance to relate very easily to people through the media and so on, but they had far more difficulties in receiving responses and data coming back to them. But with the different media developed in recent years, big data has been flourishing and producing at the same time that the necessary reduction of variety for the politicians and managers has given opportunities for creating all kinds of difficulties and generating restrictions for the autonomy and the freedom of people. And that is something that in her book, The Surveillance of Society, Zuboff has clarified to great extent. So what I would say is that hierarchical structures and technological limitations. In fact, I started working with all these ideas in the 1970s in Chile with Stafford Beer when he came to Chile to help us with the ideas of what we called in those days the CyberSyn project. And while the model of the viable system model was there, really the technology to use that model in those days was not available. Our inability to manage complexity made it extremely difficult to achieve both people's coordination of actions and responsible trust without interfering in their autonomy. This is something that with all the good intentions and the good ideas of the viable system model, simply that was not possible. The coordination of workers' activities and the coordination of enterprises in those days had far more difficult, suggested far more complexity, far more problems than the ones that could be handled with the technology available. The fact that people could meet in rooms to discuss situations was simply completely inadequate. So here, what I'm showing you is that in those days, the idea of residual variety had a limitation in its production, because simply coordination, which is the best possible way we have to support self-organization and self-regulation, simply was not supported by the technology of those days. These technological limitations made unavoidable hierarchical structures in both communist and capitalist organizations. Executive information systems were, rather than communication systems, were the most attractive to increase people's information management. In the project in Chile that I was involved, clearly our main focus was in generating an executive information system that generated, as we thought, information in real time for managers, and with that supported their chances of managing the situation. But clearly, these executive information systems were dealing with the surface of the problem. Most of the complexity of the situation in those days was in the organizations themselves, was in the environment itself, and that's where really the executive information system couldn't actually help very much. So they were very attractive technologically with the technology of the day, but they were not very good in order to support the interactions and the necessary self-regulation and self-organization. The viable system model offered a paradigm towards understanding autonomy, but still was not delivering. Today's digital technology has the potential to support this paradigm and still is not delivering. That is the sad thing. In socialist countries, hierarchies had the ideological connotation of centralization and input-output matrices as their aim at balancing complexities, albeit successfully these complexities. In capitalist countries, the ideology of the markets has proved to be more successful in managing black boxes interactions, but at the cost of increasing inequalities and at unfair distribution of wealth within the organizational systems. It has taken longer to realize that people will look for fairness and oppose capitalist hierarchies. So even if they were using the market as a way to balancing varieties between the enterprises and the markets, in terms of the internal operations, what I was referring to, the operational description of the organization, the operational description of the black box, clearly it was reinforcing inequalities. It was reinforcing an unfair distribution of wealth. And that is where the technology that we have and we still have today is not making possible the improvement of relationships. In a global society, demanding ethical responses for coordination, trust, fairness, cooperation, collaboration, as well as responsibility for the less well-off, requires solidarity among nations, requires solidarity. These nations are being forced today to cross local state boundaries towards solutions that overcome racial and cultural differences and overcome, among others, health, education, economic, and social inequalities. So in the global society, we are recognizing very much that the opportunities to relate the rich countries to the world at large are not as well developed as we would like, and produce all these kind of problems in fairness and coordination. Socially, we need to move in the direction of organizational structures that increase autonomy and regulate variety generation at the local level, as is suggested, as I have repeated several times, by self-organization and self-regulation. In the digital society, activities are grounded in technology with large capacity to create all kinds of situational states. That's what we call big data. Activities with great capacity for variety proliferation between enterprises, customers, and their environments. Algorithms, artificial intelligence, 3D printing, engineering services, and so forth are making possible for organizational systems to correct variety imbalances with their environments in real time. However, their grasp of imbalances is weak. Providers of distributed responses for environmental challenges should do that not only at aggregated levels, but more significantly at local and individual levels with the support of enabling technologies, adding flexibility and convenience. Computer networks and organizational networks are increasing relational performance beyond what was possible only a few decades ago. However, governance and inclusive processes are still failing to overcome institutional fragmentation and isolation. Many people talk about systemic thinking, but fail to understand its implication, because still we operate in societies greatly fragmented and creating failure in coordination, as I have been proposing all the time. The White methodology, which I proposed earlier, through the enterprise complexity models, has been proposed to guide managing the environment's increasing complexity through collaboration and coordination with others, rather than by attempting to go alone in this fragmented fashion. It is in this context that the methodology and the networks play their role. Beyond being modeling tools for organizational systems, they are means to deal with situations that require flexibility, creativity, and adaptability. This has clear implications for democracy and relationships. The VSM's appreciation of structures, relationships, and interactions opens the space for participation, democracy, and accountability. It is a model for democratic viability that offers opportunities to go beyond traditional socialism. Unfortunately, it remains utopia today, even with current progress in digital technology. This utopia is more than technological. It is grounded in societies and enterprises' failure to create desirable relationships, such as heterarchical relationships. People's interactions tend to go along historically enshrined relationships that they are not prepared to give up easily. That's one of the issues where however much technology we have, however good models we may have, in the end, the chances to move towards fairer societies are limited by our own inability to give up our traditions in terms of relationships. What kind of society can we think about today? This is the challenge for today's cyberneticians. Are opportunities for a renovated world emerging? For the optimists, the last 40, 50 years of social technological changes have offered opportunities for longer-term evolution towards a fairer, non-hierarchical society. For the less optimists, this is a misplaced utopia. Which kind of society are the enterprise complexity models or networks allowing us to think about? What does it mean, a society with good cybernetics? How can we realize autonomy, innovation, cohesion, and responsibility? How can it contribute to a society with more respect and less abuse of power among us? These are questions left open for us in the future. And that is what I want to give and propose to all of you. Are we ready for a society with an improved cybernetics? And that's my proposal, and many thanks for listening.
Thank you, Professor Raúl Espejo. I would gladly open the floor for discussion, but maybe I would propose to have the discussion within the section 1.3 because we are not skipping the time limit, and I know that there will be place for discussion in 1.3. Can you agree on that, Raúl?
Well, perhaps one question would be helpful in case just to.
Yeah, well, we have questions in the chat by Professor James Rose.
Just one, and then we proceed because I know that.
Yeah, I would just give the word to Professor James Rose, and because he posted a question in the.
Thank you. That's an excellent presentation and phenomenal work. I'm very grateful for that. I actually had two, but you can choose whichever one you'd like to answer. One, it seemed to me that policy relates to the notions that Michael Lissick was talking about last evening about how a story coordinates data and information, and that seems to be the nature of policy. And how does that relate to defining the limitations or expansion of the set of possible requisite variety information which comes to play? And then the second would be, does your model allow for externally introduced alternative policy recommendations that might come up along the way?
I think I'm glad Igor suggested we have a session this afternoon in 1.3 where perhaps we will talk about this, answering to your question there in relation to policies. So rather than eating the time of my good friend Mike, who is somehow they are very concerned, waiting for me to finish.
He has a stopwatch going. He did remember you promised 20 minutes.
Yes. So, sorry, I think Igor.
That's fine. That's fine. Thank you so much.
Yeah, but, you opened such a large thing that you cannot expect simple and closed questions. So thank you, Professor Raúl Espejo. Thank you also, James Rose, for posting the questions. I think it's going to open a vivid discussion in 1.3. But right now, I would like to introduce Professor Emeritus Michael C. Jackson. I could list now for the next 5 minutes things he has done and things he will do, but I will not. Please read his CV and be impressed, and I will just leave it here. But I would like to introduce the title, which is Critical System Thinking and Practice, what has been achieved and what needs doing. Mike.
Thank you, Igor. We shared a screen. And there we go. Okay, thank you, Igor, and thank you for WOSC for organising the conference. And congratulations to Raúl and the others involved in revitalising WOSC to the stage it's at now, which is really nice. And thanks, of course, to the Russian hosts. And I particularly like the relaxed atmosphere of the conference. I think it's really nice. Relaxed, apart from when Michael Lissack is around, of course. It's a very nice, relaxed atmosphere. And I'm doing this presentation with a background of an English pub, which helps me to relax as well. It's Nellie's in Beverley. Unfortunately, this pint is artificial, so I can't actually drink from it. I think this talk is very complementary to what Raúl's been saying, some of the same themes, but from a systems thinking rather than from a cybernetics perspective. So I hope that's useful. It also has commonalities, which I'll refer to with what Ray Eison's plenary yesterday and with Michael Lissack's. So again, I hope that that's helpful. Let me start by presenting an argument which I think few of you will disagree with. The first quote there, well, both quotes from the OECD. The first one, complexity is a core feature of most policy issues today. Their components are interrelated in multiple, hard to define ways, yet governments are ill-equipped to deal with complex problems, as Raúl's been saying. Now that's from the OECD, but I could have given you very similar quotes from the United Nations, from UNESCO, from the World Health Organization, from charities such as Oxfam, from an IBM survey of chief executives. Complexity is the issue. And most of them go on to argue that the kind of mechanistic thinking that we've inherited from Descartes and Newton is not appropriate to deal with complexity. And they argue that unless we adopt a systems approach, unless we employ systems thinking, we will fail to understand the world we live in. So what's meant by, if we're going to get around to doing something about complexity, we need to think about the nature of complexity. A very common definition found these days is the VUCA definition of volatility, uncertainty, complexity, and ambiguity. And that seemed to have surfaced in US military training circles in the 1980s. But it's pretty ambiguous. It's not clear, for example, whether uncertainty is about the world and lack of information about the world, which we can correct by gaining more information, or about whether it's concerned with different ways of looking at the world and uncertainty about how we should view it. So we need to go a bit deeper. Rittel and Weber did in thinking about how wicked problems arise in 1981. Here's a quotation from them. The planner who works with open systems is caught up in the ambiguity of their causal webs. Moreover, his would-be solutions are confounded by a still further set of dilemmas posed by the growing pluralism of the contemporary publics, whose valuations of his proposals are judged against an array of different and contradictory scales. So there we have an indication of complexity as potentially being seen as in the world, caught up in the ambiguity, caused by the ambiguity of their causal webs, and also exacerbated by the way the world is perceived, the pluralism of contemporary publics. And the philosopher Rescher wrote a nice book in 1998, which is a philosophical view on complexity. He's a pragmatist philosopher, Rescher, and many of the philosophers that I will quote are pragmatists. But Rescher makes a distinction which mirrors that of Rittel and Weber between ontological and cognitive complexity. I guess these things are fairly self-evident. Ontological complexity is is about the variety of elements in the world, the number of elements, the variety of elements, and about their interrelationships. So again, it refers to us looking at the world and seeing complexity there, what is in the world, ontological, what exists in the world. And he distinguishes that from cognitive complexity, again, which is how we actually see the world. And that contributes equally to the difficulties that we face in dealing with complex problem situations. I was on my way to watch Hull City play football last night. I was 10 minutes late getting to the game. And the reason was that all the petrol stations down the roads on the way to the MKM stadium were blocked by people trying to find petrol, diesel, find fuel, and petrol stations which had fuel. There are actually as much fuel about as there ever was. There were as many tankers on the road as there ever was. The problem situation, the complexity, is caused by people believing that there's a petrol shortage. It's cognitive complexity that is creating the issues, the problems, the difficulties. They believe there's a petrol shortage and they cram into the petrol stations and they create a petrol shortage from doing so. Anybody interested? Hull City drew a 1-1. So given that it's useful to think about ontological and cognitive complexity, how should we go about approaching it? Systemic perspectives on complexity I'm discussing now. And I particularly like the work of Edgar Morin, 2006. He's written about it in books, but there's a 2006 article which summarizes it very nicely. And he says there are two ways in which people try to handle complexity. One is by treating it as a case of restricted complexity. They seek to use computational modeling techniques to tackle it. This can be helpful. It increases helps with formalization and with interdisciplinarity often. But for him, it remains within the epistemology of the classical sciences, as he puts it. It's still looking for underpinning cause-effect relationships, which give rise to explanations of how surface phenomena arise. And he thinks that's impossible in terms of the complexity we face today. I mean, examples of a restricted complexity approaches are perhaps traditional system dynamics, which attempts to find the underlying cause-effect relationships, feedback, feed-forward loops and lags, which give rise to surface phenomena. Or from the complexity theory perspective, agent-based modeling tries a similar computational modeling technique. For Moran, in dealing with the complexity we face today in the major organizational social problems, we have to treat it as general complexity. Complexity provides unknowability. It resists universal truths. And because of that, we're operating with a whole set of partial truths. And so the fundamental problem, it shifts from the ontological to the cognitive in Rescher's terms. And for Moran, the fundamental problem becomes epistemological, cognitive, and paradigmatic. How we actually work with partial truths to try and get some handle, some kind of traction on complexity. So the issue for me became, I mean, you could have whole hosts of partial truths. So the issue for me came what types of partial truths could actually be useful for us in seeking to understand complexity and in seeking to do something about complexity. What are useful distinctions to make in dealing with complexity? And a clue for me came when I reread Pepper's work, World Hypotheses, which was written in 1942. And Pepper argued that if you go through the history of philosophy, you can find certain partial truths which are proven to be successes of cognition, in his words. They've served us well as successes of cognition. They're creative discoveries of generations. We've learned to live with them, and we've facilitated their development, and we've improved these world hypotheses over generations. They've served us well. And that kind of thinking was reinforced when I read Lakoff and Johnson's work on metaphors we live by. And they refer to sets of experiential gestalts, gestalts ways of thinking, systemic perspectives, I call them, which are proven useful to us in seeking to understand the world and to make our way in the world. So what I did was to have a look at the world hypotheses that Pepper elaborates and the experiential gestalts of Lakoff and Johnson and social theory more generally, work on paradigms and work on metaphors in social theory, to try and come up with a justifiable list of successes of cognition or experiential gestalts, which we could say were useful partial truths in attempting to make our way in the face of complexity. And that's my list. And I don't think many of them will be surprising to you. The mechanistic vision has proven extremely useful and powerful in the history of the human race in coming to terms with the natural world and in organizing and coming to terms with social reality. So has the organismic vision, thinking in terms of parts and how they function to serve the whole and how wholes operate in their environments. So has what Pepper would call the contextualist vision, whereby different worldviews based upon different observations take us towards the purposes that different individuals or groups pursue. So has the societal environmental perspective, looking in terms of advantage and disadvantage to different groups in society. And so has, I think, a specifically systemic view, the interrelationships perspective. Each of these represents a partial truth, which somehow has served humanity well. And developing these partial truths, I think, can continue to do so. And that's a role that systems and cybernetic thinking has done better than anything else, I believe, in translating these world hypotheses into means of taking good action to bring about improvement in the world. Pepper puts it like this: the gears grind, the lights flicker, and the lenses distort. So they're partial truths. Nevertheless, we do seem to get some idea of our world from these vehicles, and without them, we would have to walk pretty much in the dark. Now, let me pause there to make 3 points. The first point is to relate my talk to the interest of perhaps the majority of people at this conference, inside their interest in cybernetics. I think you'll see the relationship between the history of cybernetics and an exploration of those world hypotheses. So Wiener first defined cybernetics as the theory of communication and control in the animal and the machine. He was looking at, he was developing the mechanistic and the organismic world hypotheses. First order cybernetics continued to do so. Second order cybernetics, I guess, pays much more attention to the role of the observing system, and therefore to the purposes of the observing system and the way the world is perceived. It seeks to develop the purposeful systems paradigm. Third order cybernetics and what some people are calling critical cybernetics is a reflection of an attempt by cybernetics to operate in and develop the societal environmental world hypothesis. And the interrelationships perspective, well, cybernetics has done perhaps more than anything in developing that with its notion of causal feedback, mutually reinforcing causal feedback loops, and that negative feedback, of course. So there's a link there with, between systems and cybernetics, and as I come on to look at systems in terms of these world hypotheses, perhaps that'll be helpful in making that link. A second point is in relation to Ray Eison's plenary yesterday. He gave us a sort of a summary of the development of systems thinking in historical terms, which was extremely useful and absolutely necessary. It's essential that we know the history of our disciplines, how our disciplines developed. We don't want to continually, as many consultants getting onto the systems bandwagon these days do, reinvent the wheel. But it can become a list of names, a list of different theories, and a list of different methodologies and methods. And as a number of people have pointed out, we do to some extent need a helicopter pitch to get across our ideas. And I would argue that looking at systems and cybernetics as operating and developing these 5 world hypotheses is one way of simplifying the field and enabling it to be taught. An option is that Cabrera's version of systems thinking as somehow a reflection of 4 key concepts: DSRP, distinctions, systems, relationships, and perspectives. I would advise you not to go down that route. And my third point, here relates to Michael Lissak's plenary yesterday. He was talking about shortcuts, and he saw the necessity of shortcuts, but he saw them potentially as leading to sloppy science. I'm not sure of that, particularly in the social realm. I think shortcuts are necessary for us if we cannot understand, we cannot get to grips with general complexity, we cannot have a universal theory. So we need some shortcuts which have proven successful to us throughout our history as a human species. And I offer you these as the shortcuts which have have in fact done that. They're useful experiential gestalts, successes of cognition, creative discoveries of generations, and we should be proud of them. And they're not in any way sloppy science. They've been well elaborated and well developed in the literature, and I invite you to, of course, look to see if my particular working through of these five perspectives is good or sensible, or whether others could be added. Anyway, here's the good news, because in systems thinking, as in cybernetics, we've attempted to come up with methodologies which respond to these experiential gestalts. In other words, I can claim that if we've had 5 useful ways of looking at the world that are proven potentially beneficial to the human species, then the good thing about systems thinking, as it's come up with 5 types of methodology which correspond to those experiential gestalts. And therefore, we have developed 5 ways of seeking to improve the world, which correspond to the good ways of perceiving the world. And we can be proud of that. I think. So mechanistic thinking has given rise to approaches such as systems engineering, to lean systems models, Deming's work, the Vanguard approach, orientated to efficiency and efficaciousness as the main concerns of the mechanistic paradigm. The organismic worldview has given rise to socio-technical approaches based upon Bertalanffy's work originally. The viable system model can be used as an organismic methodology model in this way to aid the organismic approach. And the concerns here are with adaptability, resilience, anti-fragility. Much progress made in the systems community on those items. Compare what we're able to say with what, for example, Taleb is able to say about how actually to achieve anti-fragility, and you can only be impressed by the achievements of the systems and cybernetics movements. Purposeful systems thinking has been developed and expressed in the soft systems approach of, I suppose Akoff is the systems philosopher par excellence of the purposeful systems approach, but also the well-known work of Churchman and Chekland, the concern with doing the right things, with being about mutual understanding, with avoiding groupthink, with achieving accommodations, of finding ways of dealing with conflict. And the societal environmental approach, giving attention to marginalization, disadvantage, inequality, and environmental issues, and the concerns of future generations, is taken into account in emancipatory systems approaches such as critical systems heuristics. And the interrelationships approach, system dynamics, where you can look at you can look for unintended consequences or leverage points which might help you to bring about change more easily than might otherwise be expected. So we've developed approaches, and I'm very proud of this, which enable us to react and correspond, which correspond to the main key ways of looking at the world that have represented cognitive successes. Now, I started by saying there's a huge demand for systems thinking from bodies like the OECD, the World Health Organization, etc. And what we're perhaps failing to do, what more could be done, is to meet that demand. And we are in a position to meet that demand from the cybersystemics community. So we're doing something wrong. But let me first of all just illustrate again that demand and what it is that we can contribute to meeting that demand. First of all, I'll just whip through this quickly. This is a critical systems thinking approach to what we said so far. And it's a summary in a sense of what I've been saying. So critical systems thinking is an attempt to make use of these different systems approaches, is a pragmatic approach to general complexity, and we have to learn by engagement with the world. We cannot in advance understand the world enough. We have to learn to engagement with it. If we want to do that successfully, we need to be multi-perspectival. Pepper says in that quote there, we need all world hypotheses so far as they are adequate for mutual comparison and correction of interpretive bias. Multi-perspectival. If you're looking at the COVID epidemic, then it's worth looking at it from a mechanistic lens, the logistics of developing personal and spreading around PPE, organizational, the difference between centralization and autonomy, mutual understanding, and inequality. All these lenses are useful for looking at COVID. You can adopt a multi-methodological approach, a second order approach, where we, in Luhmann's terms, become interested in the distinctions with which observed observer works. Different methodologies making different distinctions. And we need to be flexible. A recent quote there from Kay and King, talking about radical uncertainty. It's Scott Fitzgerald's thing about keeping two things in your mind at once. And they say the mark of a first-rate decision maker confronted with uncertainty is to organize around a reference narrative, but still being open to the possibility that this narrative is wrong and alternatives might be more relevant, shifting narratives and seeking general improvements. But back to my point, how can we help? How can we do better? I was at a conference last week, just down the road from you in Moscow, at St. Petersburg. It was a project management conference, and they were looking at rethinking project management. And I remembered a report that had been done on rethinking project management, and I came up with this list of the things that they were saying about rethinking project management. And this is the list that a report, an EPSRC report in the UK came up with. And I've not altered the conclusions at all. Improve project management by developing its foundations. Explore other than the positivistic perspective they were saying. There's a need for multiple images, partial theories, to guide us in the face of multidimensional complexity. Traditional methodologies upon which the approaches relied, hard systems approaches, are no longer on their own suitable. They need complementing with alternatives that focus more on the flux of events, on human interaction, on politics and power, on focus on stakeholder service, value creation, rather than the creation of one product. All these things can be taken into account, I believe, using the latest forms of systems thinking. And I made the case to the project management conference. Here's where we can help. Here's where we can engage with you to bring systemic thinking to bear on project management. There's been some successes. I've been talking to the International Centre for Complex Project Management, and their initial standards were to some extent influenced by critical systems thinking. I was talking to Jose Leos and to Pantaris from Valladolid University, and their syllabus there takes into account a variety of systems approaches. Here's another example. I've been looking at the health systems research community, a huge community of systems thinkers. Their conferences have about 2,000 people who claim to be interested in systems thinking and looking at public health and public health problems from the systems approach. But they know very little about what we would call cybernetics and systems and the history of it. And yet they know they are in difficulty. And Luis Sambo and I looked at their literature, and this is what you get from their own literature. You find that they're committed to the notion of complex adaptive systems, but they've no idea what that means. They fall back on a restricted notion of complexity, as Moran would put it, usually in the form of system dynamics. Very little from cybernetics or the viable system model or soft systems thinking or emancipatory systems thinking. They fail to understand the strengths and weaknesses of different systems methodologies. As they themselves say, they fail to take advantage of the range of methodologies we have. They don't know how to understand coherence when they have diverse knowledge paradigms. These are all things that we've addressed in the cyber systemic community. And they have difficulty evaluating the success of their initiatives because they're only capable of evaluating them in mechanistic terms as is required by their funders. My argument is that we've achieved a lot in the cyber systemics community. There's huge demand. You can see that from project management as one example, from health systems research as another example. We've got somehow to get our ideas out there so that we can engage with these communities and make sure that what we have to offer actually can bring beneficial change to the organizations and the world in which we live. Thanks very much for listening.
Thank you, Professor Mike Jackson. Actually, I think you answered several questions which were open and open many more. And more than that, you opened opportunities, which, yeah, it's so important. And I can see raised hands there by a fellow, I think I've met him before. Hey, Hassan?
Thanks, Mike. That was a nice talk. And like you, I agree with 95% of what you said. So, but I'm not necessarily going to pick on the 5%, but I didn't. Just on your last point, I mean, I agree with you about the health systems work, and I've been working with that community for a number of years now, and things are slowly starting to shift.
Yeah.
We're about to have a food systems summit, UN food systems summit. And my colleague Kevin Collins and I have been trying to get a critical paper published in Nature Food Systems to critique their use of systems, but can we get it published? No. My question really, though, is given what you've said, how would you put or elaborate the theories of change that a practitioner might hold under your different typology of approaches? And do too many practitioners in policy settings or in the cybernetic community still hang on to the what I would say is the mistaken belief that there is a thing called prediction and control?
Yeah, yeah, a difficult question, Ray, but absolutely opposite. Let me refer to the health systems community. Clearly, they found that individual initiatives to, for example, get rid of malaria or other diseases of that kind, and it was required by your funders that you had a fairly mechanistic approach to it, and so that you could evaluate success very, very quickly. And that's one of the issues, of course, how you evaluate success. And funders want, like Bill Gates Foundation wants immediate results with so many people vaccinated, so many people. But these things are put in place, and then there's no resilience. The thing can't sustain itself. The health systems are not strong enough to maintain the success. And so health systems researchers started looking for alternatives, and you can, like you, I wrote a paper with Louis Samba, who was the director of the World Health Organization in Africa, and led the response to the Ebola outbreak. I thought it was a pretty good paper, going through health systems research and looking at their approach to health systems, and finding it, certainly making the point that it was an improvement and was a way forward in terms of what they'd been doing previously. But there was much more in systems and cybernetics that they could learn from, and we needed an engagement. And we were equally at fault in systems and cybernetics because we hadn't got our ideas across to them. They had their own gurus, and we'd not engaged with them. We'd not engaged with them properly. The response has been disappointing to that paper, in my view. Nevertheless, like you, I have now opened some dialogues, and I'm talking to the Alliance for Health System Strengthening. And there does seem a willingness to engage now, and we need to take advantage of that. So I don't think I've answered your question, but perhaps I've elaborated the same sort of thing that you were saying.
Okay, since Ray is kind of satisfied with the answer, any more discussion? Let me point out that when we open the rooms, we don't only open the sections rooms, but we also open the rooms for discussion. So if you have somebody who would you like privately to discuss something, you can go there and have a private discussion. And yes, I can see a raised hands by Professor.
Could I just come back on what I was saying to Ray? And it's not to answer the question, but to say that the examples Ray gave food. I'm just looking at the chat. The food summit, and they know little about systems of cybernetics, so they talk in systems terms. Similarly with health, similarly with project management. But you could give examples all over. The Institute for Chemical Engineers gave a report to Parliament talking about systems thinking being necessary for all engineers. The Institute for Civil Engineers has just produced a report looking at systems thinking as absolutely essential for infrastructure development and civil engineering. The systems engineering community has been going on for ages about how to broaden its methodological approaches so it can deal with greater complexity. The opportunities for us are massive. I'm asking the question to this audience of why we're not succeeding in bringing what we feel is the strength of the cyber systemics community and having an impact on these groups which are more practitioner orientated than perhaps we always are. I mean, my feeling is that we do translate world hypotheses into practical methodologies, and it's exactly what these groupings need to improve both their theory and their practice. Sorry, Igor.
Can I offer a reason why you don't succeed?
Yes.
Igor,
because
I think we are past the time now. And,
yes, well, let me allow a fast feedback between Mike and Shan, and I can see Victor Simov is having his hand raised, so let us close these two loops and then we'll proceed. Yes, Shan.
Okay.
Am I to speak or not?
Yes, you are.
I see the practical problems is the governance problem, and we have upside down governance. We have governance by command and control hierarchies where you've got to have it reverse it, the pyramids of power. And there's too much focus on models. There's a fellow in 2.2 last night from the UN, and he had that complicated model. Maybe not everybody saw it, but he was trying to, but he works for models and try to make it practical. It's a bit like VSM. I mean, it's a marvelous model, but it's a matter of engaging with people. It just phases people out of them. When you see Rao's, presentations earlier. So I think you've got to approach it from the governance angle, that there's a systemic governance problem throughout the world of command and control hierarchies which deny feedback. They deny variety. They block out variety of control. They drop out variety of communication. They deny variety in decision-making because they're unitary. They have one central board of control, and you can't get any systematic things working with a centralized control. The human mind has no chief executive neuron. Nature has distributed control centers competing with each other. We do not have that in social institutions. And I've been talking to people that run the Patients of Canada. They want to empower patients to take control of the specialists because it's so centralized. So I see it as a power problem, and that the models don't take into the, and Sapir said to me directly to me, he said he'd never considered governance. It was always at the grace and favor of management within the organization.
Well, you're right. You're right, of course, that which world hypotheses actually are able to come to the fore and influence the way we work depends upon power structures. I mean,
they're upside down. They're not receptive to change.
That issue is, and therefore some of the other world hypotheses that we might want to bring to the fore, and some of the other systems methodologies that we might want to explore and use, are not used as much as they should be because of hierarchical power structures. And that's the impact, that's the issue that we're working with and against. I guess Ray would say in the food systems arena, and I would say in the health systems arena, there are particular power structures which have an impact upon which kinds of systems approaches are popular and which are not.
Okay,
I agree. So we're in serious agreement.
Sean, let us.
Yeah.
Yep.
Thank you.
Because but Victor, is it possible to have a short communication?
Yeah, very short question. When you are talking about complexity, I think that from philosophical point of view, we have to divide complexity into two parts: qualitative complexity and quantitative complexity, like information complexity and knowledge complexity. It's like analog. What do you think about this diversion of complexity? Thank you.
I'd need to know what those distinctions exactly mean. I mean, I was relying on Rescher's ontological and cognitive. I mean, these are all ways of doing it. To me, we're just faced with bloody complexity. And we need to try out and engage with it on a pragmatic basis to see. I'm interested in what works, what differences make a difference in the world in terms of improving it. And therefore, I'm not all that interested in different definitions. And I certainly don't like these lists of non-linear and 15 different points which define complexity. I don't find them particularly helpful.
Igor, can I ask, does anybody like to go into a private room and educate me of why we need more orders of cybernetics? It just mystifies me, all these social constructs. I need an education.
We'll do it, but let's
Sean,
go with the flow.
If you want to discuss how many orders of cybernetics,
why we need any?
Sorry,
why we need any?
Session 1.3, sorry, later on. And
okay.
At this point, I was asked to moderate the time here, and the same one who asks me to moderate the time breaks it. So what can I do? And respect for the time of people is central. And in this case, I want to respect the time of my good friend Igor Perko, who has the responsibility to run the next session. And I don't need to introduce Igor to you. You have seen enough of him throughout this time. And I want him to have a very successful presentation of what he calls hybrid reality and data sharing concepts proposal. Igor,
thank you, Raul. Thank you, everybody who is prepared to hear that, and hopefully at the end provide some advice. Can you see the screen?
Yes.
Perfect. Now, I would like to first go to the hybrid reality definition and throughout the circles to get to this last part where I'll try to discuss data sharing versus data collecting concepts, and then I'll ask for help. Okay. Here we go. Hybrid reality was defined in 2020 as a time frame, right? Where we get a new player in the system, which is artificial intelligence technology, and he's introduced only gradually, right? But to be a member, to be a stakeholder in the system, it really needs to develop three capacities. And that's the capacity to sense, the capacity to reason, and this is currently called artificial intelligence, and the capacity to act in the hybrid reality world. The problem is that each time period has an end, and it ends with the relationship between the artificial intelligence technology, the new player in the game, and the other stakeholders are becoming stable. Now, the question is how it will end. Okay. Now, we tried to put some backgrounds to understand what the hybrid reality actually is. And one of the components is basically artificial intelligence technology, which currently looks like that you have a smart device, a cloud environment somewhere out there, and then you interact with a remote controller to that, and basically have that invisible connection between devices and you, and also smart devices within your hands. The second one was, to investigate how the new player in town is basically developing. And there is one method, which is learning. And we use this cybernetic loops, which I will not comment on because if you don't know it, then I don't know. But the second one is evolutionary, right? And I think you know this is a Darwin picture from Galapagos Islands of a bird developing. But we are not facing this kind of evolution. We're facing this kind of evolution, which is guided, right? And yes, these are all birds, and you can see that it's a deliberate evolutionary path. Now, to elaborate on the model, we used adapted system dynamics model, where we said, okay, we are looking at the dynamics of the interactions between participants, between the stakeholders, and from that we can identify the level of activity of particular stakeholder. So the question is, what is going on with that? And the last paradigm, we explored the nervous system emergence, which I think it is going on right now. So what we have the nervous connections putting on globally, connecting. What we are missing or finding is basically the brains. I do assume that we will not have a central brain, but we will have multiple brains, which do connect and do reason on the global level. So these are the background propositions for the model, right? And we tried to simplify the model up to the point where it is understandable to people. Okay, if you look very close, very swiftly through that, the central point of the dynamic goes between the ICT providers and smart devices, where local and global reasoning are put in. And those lines are very short and very fast. Well, it affects organizations, individuals, and natural environment. We did not want to leave the natural environment out of the game. It's a stakeholder, mostly through services and activities. But in another direction, there is a sensor and communication data. What we found especially problematic is the link between the players and the regulators, because the link is delayed through moral and ethical norms, through reports, and there is another delay in regulatory frameworks. So we see this asymmetry in dynamics in the whole system. Now, let's have a look at what is going on with the stakeholders dynamics. So we are looking at, are they becoming active or are they becoming passive? And if we look at the AI technology, they're a clear winner. right? They are becoming connected. They observe. They are actively involved. They are becoming intelligent. So this is not a state. This is it's a process of. Now, I wouldn't downpoint the self-reproductive part, because the speed of the evolvement, the speed of learning, and the speed of the next generations coming by exceeds very fast when people as developers of artificial intelligence technologies go out and are replaced by artificial intelligence technology itself. So this self-reproductive part is considered to put additional gap in the dynamics of the interactions. Yes, and we do expect that at some point it will actively co-develop the new reality we're living in. And frankly, it's a fact. It will happen. We don't know when. We hope that not soon, but we should consider them as the really active part. Now, what is going on with organizations? They have some organizational strength, so they can cope, they can produce some dynamics. So it looks they will remain. We have more problems with individuals. Currently, we are not coping with the demands of technology. I don't know what will happen in the long run. Even with augmented people, or hybrid people, or super people, people themselves will be always on the passive side, and we will be decreasing from the active state to the passive state. We could see that regulators are even on the slower side because of the delays in the communication and poor natural environment. Natural environment has no agent to speak in its name. So basically, it will become passive. What does that mean? That means it can be exploited. People can be exploited. Regulators can be manipulated. The more passive you are, the harder it is for you to follow the changes. So when we look at the picture that could happen, I don't know. I find it's quite problematic. Well, we didn't go to picture out the black picture. We tried to find how the stable final state, which we may look like. And the concept is basically to, first of all, develop a very wide range of concepts that you can rely on. So the base foundations which do elaborate on the relationships. And this cannot be, you all know the Asimov's 3 theorem of robotics, cannot be that simple. The variety of the fundamental concepts need to somehow be aligned with the complexity of the system. But these are crucial. AI technology, organizations, individuals, and natural environments will somehow need an agent to support them in this new reality. Somebody who is on their own side. And frankly, with the dynamics of the AI technology, on one side, you will need an agent which works on your side, built by AI technology. It's a problematic concept, but it looks like this is the only way to avoid the passiveness of organizations, of individuals, and especially natural environments. Imagine that natural environment has an agent who works in its name. Okay. And above that, there are regulators who are actively engaged in sensing, communication, reasoning, and providing services and activities. Those things need to be regulated. Of course, not directly by the regulatory frameworks. We can discuss that diagram. It's been published in Cybernetics, but it's an interesting one. Okay, I will. Yes, that's basically description diagram. So I will skip that. Okay, the next question is, can we do something about it? Where? How? I don't know. Maybe like that. You know, AI technology needs capacity to sense, capacity to reason, and capacity to act. And from my perspective, all three aspects need governance. And that not need management, but governance, because artificial intelligence will be included in the governance. But capacity to sense has to be governed, capacity to reason has to be governed, and capacity to act has to be governed. And all three should be addressed. I'm afraid that we do not have the time or the effort to go into all three of them, but we can tackle capacity to sense. Yep. There is a comment on there, which I put for me, that, you know, the governing mechanisms employed there should match the complexity of the environment. Okay, so that we cannot just say, okay, we'll use some simple general rule sets and it will work. I'm sorry, it will not work because the environment which we would need to govern is extremely dynamic and extremely complex. So some thinking has to be done here, how to effectively govern these three fields. And here's the proposition. Let's see about the sensing. First of all, I think it's important for us to clarify which data are we talking about. What is that? Is this our security number? Is it our first and last name? What's the data we're talking about? And it's about detailed data. And this is data which AI needs to reason upon the people or environments to understand their motives, their activities in the hybrid reality or the real reality. But you know, it's not enough that you just know which movies you like, or how do you like the weather? Do you like warm weather or cold weather? It's a detailed data which comes from observing people. And I have some examples here down there. For instance, we're talking about biometric data, like body temperature, eye movements, station points, so basically to know where you're looking at, heartbeat, skin moisture. And this is not just data on once a year. This data is transferred extremely regularly. For instance, eye movement in milliseconds, heartbeat in minutes, right? So it's a flow of data which feeds artificial intelligence. Without that data, artificial intelligence cannot reason successfully, right? We can continue with mouse movements, keyboard strokes, all kinds of things related to the situations we would like to observe. For instance, if you're going by the pub and you look at the pub, and that means that you are maybe interested in going there in this particular situation. This is something which AI finds interesting. Okay. Now, if you're talking about environment, it's about ground penetrating data, water, oil, and mines content, fish, krill swarms, level of methane in farms, etc., etc. So all this IoT data, which is being collected, and frankly, we are starting to do that, is interesting for AI. It needs it. So we're talking about any data that can be sensed using IoT devices. So this is why we're calling it sensing data. And this is the data we're talking about. Okay, now, currently, what we are doing, we are using the concept on the left, which is data collecting. Data collecting is extremely efficient. You know, you collect the data, store it in data lakes, manage it, use it. Who does that? The organizations who have put together the streaming part and the storing part of the data. And they analyze it. Basically, analyze it means they develop AI algorithms. And it is focused in that. It's a very optimized process, and it will get to be even more optimized. So the idea is put the data in with as little effort as possible and supports the AI reasoning, because this is what it is for. Let's use it, right? It's collected from individuals, from organizations, from the environment. I must tell you that right now we are streaming that through Facebook. I have no idea where this is going to go. Okay. Let's see if we can find a different concept. Remember, it has to be wide enough so that it allows governance. So the data sharing concept introduces the notion that, you know, data are an asset and they should be owned by somebody. And who should own it? Well, the data producers, individuals, environments, social groups, etc., organizations. And the data that is produced by you should be owned by you and share it actively. That means that you decide to share it according first to individual values, and of course, because we live in a society, there are social norms which sharing needs to apply. And really the focus of the concept is understanding data as an asset and preserving the data ownership rights. Why is this so important? Because data ownership rights are defined. Currently, data is greenfield where everybody can feed on because data is not being a category of ownership, right? But what does it imply to? Well, it implies to the ethics, because the ethics as a collaboration between individuals and the society will be redesigned. It will affect ethics as a in the ground level, putting the new concepts into the play. Absolutely law, regulatory frameworks. We need to discover how the society responds to that. So a lot of social research, social examinations need to be performed. It will affect the process of acquiring data, storing data, and basically using data for reasoning. And the funny part is that we assume that we will need to have a negotiation to get to the distributed data. So not collected data in data lakes, distributed data, and before you can access it, you will need to negotiate for it. And obviously that will majorly affect businesses, organizations, also the ICT providers who are, I'm pretty sure, will not be happy about the concept. Now the data which is really accessible will have an owner. Okay. We have applied for a product which will try to elaborate on this particular implications, which we listed. But yes, we are short now. We need help and advice. And yes, that would be from me. And yes, any advice, any help, any suggestions, comments are more than welcome. You are my Delphi group. Okay. Thank you. Raul, you're muted.
Okay, thank you, Igor. Now we are back into the main room with all the participants. And any questions?
Yes.
Marcus.
Yes. You said something interesting. The natural environment cannot speak up. And that's an argument I have heard for a long time. And I always said, well, I talked about the future generations. I said, if they cannot speak up, we have to simulate them. Now, today, we need not simulate anymore because the nature speaks directly. Inundations, droughts, falling biodiversity, and so on. And we have NGOs who defend these issues and scientists who do the same. So, but I feel you want something different. But what would be your idea of a natural environment speaking up?
You know, frankly, when I was speaking about the negotiation layer, right? Currently, what we do with the environment, we are exploiting it, really. First exploitation, then waste, both of those. And those are being measured. And, you know, I think that the the data that comes out of that should go to the right entities, the right organizations who can speak for them and does not allow overall, you know, using of our natural data, our natural environment. So, for instance, if you have an oil corporation that does the researches new fields with what is that blocking or breaking, right? Terra breaking. They are not entitled to this data, but the organizations who do support, who act in favor of the nature, they are. And this is something. This is, you know, you cannot exploit something you don't really know. And if you're not qualified to do that, sorry, you cannot get the data because it's not owned by you. It is owned by the nature. And obviously, this nature needs some kind of an agent to actively speak for it. Because it does speak to us, but we don't understand it. I'm sorry, we don't get the message. Another tornado. Okay, we don't know where that came from. We get strong messages, but we do not understand it.
Thank you.
So another question?
Yes.
Who is there? Pirani, Massimiliano.
Sí. Igor, you said that the hybrid reality system is based on the capacity to sense, reason, and act, mostly, no? Mm-hmm. But you know that these three capacities must be shared between artificial and human beings, And so I think that the focus of the research must be there in this new kind of reality that we still don't understand very well. Because as you said just before, you receive messages, but the semantics of these messages today is shared between humans and machines. And we understand in two ways, in the way of humans and in the ways of machines, but not in a unified way. Do you think that it would be possible or would be useful to search in that direction?
Yes, if I understand it correctly, you know, it's about it's about capacity to understand, and not only to understand, but also in the dynamics of the communication.
Yes, of course.
For instance, if you are sharing, I don't know, if you are a cancer patient and you're sharing your data with the hospital, right? It should be clear that you're not surrendering your data to the hospital to do whatever they like with that, but for them to ask you each time they want to use your data in their research, is this okay? We will send our data of our patients to an international organization which does research cancer, and they will ask you, can we do this analysis? And then maybe this data will go to the pharmaceutic, will want to be examined by the pharmaceutic company. And again, they will need to ask you, can we please analyze, use this, your data for our analysis? Now, the problem is in our capacity to decide on all of these things, because frankly, who reads that? Nobody. Who reads the terms which are behind the I do accept, the cookies?
Yes.
Can you please, anybody of you, raise your hand? So this is beyond our capacity. And that means we need an interpreter. Somebody who understands and can manage the complexity and dynamics of the artificial intelligence part of the hybrid reality, and works for us without without being compromised by the interest of commercial or any other kind to basically share our data, or and there the digital yes.
Let me just mention that yesterday we had a presentation by a Peruvian about precisely how to give the word to nature itself. And what is also interesting now is that in Chile, with the new constitution, this is a debate to what extent the nature will have its own word in connection to the decision making and all of that. So it is a topic that is being discussed at the moment, and I suspect that there are many people who are following that. However, there is one question that I get. Elena Malakova is asking for something.
Mm-hmm.
Elena?
No, I wasn't asking.
Oh, you put your hand up.
No, I didn't.
Oh, you did. I'm sorry.
No, I think she agreed with.
But Sean
I just agreed with Igor.
There. So Sean, let's go to you now.
Igor, I put a suggestion of way the environment can speak to us by tethering money to a sustainability index with metrics, objective metrics on a rolling 5-year average of the degradation of the atmosphere, the water, the soils, and biodiversity. And so you get the invisible hand directing, looking after us for sustainability. That's all.
Yeah. I like the comment. We could actually go further on, because in generating financial KPIs or something like that, it's a derived metrics. we could go and tackle the problem on the operational level. That means you can see what is going on with the nature. For instance, how much rain did we get? What's the temperature? And these are measurable facts and are being recorded. And yep, so we can actually be even faster, even more direct.
I've got a big literature on it I can share with you offline later.
I would love that.
Very good, because we have reached the 10 o'clock or 12 o'clock time in Moscow. And so we have now a break, and we are meeting at 12:20 in the rooms. So now the word back to you, Igor. You can help us.
Okay, back to the moderating, Igor. Okay. Yes, if you agree, I could open up the rooms, so you can have coffee within your sections rooms. Today it's section 1.3, 2.3, 3.3, and section 4.3. Or alternatively, you can also, if you have a direct communication, you can go to one of the private rooms. I think we opened just 2 of them. So most of you will stay in the sections, but yeah, if you want to have a coffee with somebody, just go to the private room and have a coffee. Okay, and see you in
20 minutes.
17 minutes.
Yes, that's even sharper.